Hey guys, in this video we shall see another problem on LeetCode can place flowers. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be placed in adjacent plots. Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n, return if n new flowers can be planted in the flower bed without violating non-adjacent flowers rule. So what the question? Let's understand this with an example. 1 0 0 0 1 and n equal to 1. So if n equal to 1, what does it mean? If n equal to 1, one flower, we have to check whether we can add one flower in this flower bed or not. Whether we can plant one flower in this flower bed or not. So how to do that? I have told that no adjacent plots must contain the flowers. So 1 means there is a flower in this flower bed. Here 0 means there is no flower in this position. So here it is 1. So you can't place this flower one flower here. Then come to the 0 second position. Yeah, it is empty. But if you observe the previous value to this previous position to this is having flower. So you can't place over here also. It's coming to third position. Yeah, it is 0 and previous also 0. The next one further forward one also 0. That means yeah, adjacent to this position there is no flower actually, so you can place the flower. So at this time we have placed one flower. So this is what the question is. So how do we solve this question? So for solving this question, there are uh, three cases which you have to consider. One case is what if the length is 1? Length of the flower bed is 1. It's given in the array format. So if the length of the flower bed is 1, it can be either this or this. In such case, we have to check whether this element in the flower bed is 1 or 0. If it is 1, no, you cannot add. If it is 0, yes, you can add. And let's initialize a count variable, count equal to 0. We have to perform these operations until count not equal to n. Once in encounters count equal to n, you should stop performing all the functionalities. Count equal to n. What is n? N is the number of flowers that need to be planted in the flower bed without violating the no adjacent flowers rule, right? So yeah, we have this variable count equal to 0. So if initially there is flower bed containing only one item, and that is 1, and given n equal to 0, then you have to check if count not equal to n, and this flower bed of 0 is equal to 0, then you have to perform count plus plus. Otherwise, you need not to perform count plus plus. So if the given, let's imagine the given question is n equal to 0 and only one element in the flower bed. So in this case, is count not equal to n? Count is 0 initially. Yes, it is equal to n. So you need not perform this one. So you just come out of the loop. And after all the condition, you have to check if count equal to n, then return true, else return false. Yeah. So count equal to n, 0 equal to 0, yes, you return true in this case. For this, it's true. What if n equal to 1 and the element is also 1? So in this case, if you observe, is count not equal to n? Yes, it is because count is 0 and n value is 1. So count not equal to n. And count for the flower bit of 0 that is containing 1 as element. Is it equal to 0? No, it is not equal to 0. So this condition will not happen. That means you cannot place a new flower in this flower bed because it's already containing one flower in this and it has only one position. Hence, Do you get count equal to n? No. So you return false. In this case, you cannot add a flower to the flower. So next comes the other case where n equal to, okay, element will be 0. That single element will be 0. If it is 0, then count what will it be? And n equal to 0. And again 0, n equal to 1. If we take n equal to 1, that same case will apply for n equal to 2, 3 anyways. Yeah. So first element is 0 and n equal to 0. Is count equal not equal to n? No, it is equal to n. So you need not insert any flower in this flower bed. So that's why you return true. Count will be equal to n. So you return true. But here it is 0 and n equal to 1. That means you have to insert one flower in this flower bed. So you check count is not equal to n. Yes, it is not equal to n because count is 0 and n equal to 1. And flower bed of 0 is nothing but 0 only. So there you go. Hence you increment the count value. Count will become 1 now. So count value became 1 means yeah, you have inserted one, you have planted one flower in the flower bed. So yes, you are able to plant a flower in the flower bed. Hence count equal to n, 1 equal to n. Yes, it is true. It will return. So this is one case to handle in the question. So other case will be, what if the beginning of the array is containing 0, 0, 1? Yeah. In this case, you could see flower of 0, f of 0 is equal to f of 0 equal to 0, f of 1 is also equal to 0, and count not equal to n condition also has to be checked. So why am I telling all these three conditions? Because you'll get to know later. And how did I come to how did I come to know about all these conditions? Because when I was solving the problem, few test cases was not passing, and by that test case, I could figure out what conditions I have not been handling in the program. So yeah, so f of 0 equal to 0 and f of 1 equal to 0. Yes, it is. And count not equal to n because count initially will be equal to 0. And let's imagine n equal to 1. Yeah, these are not equal. This condition satisfied. That means you have to increment count plus plus. Now, once you increment count plus plus, that means you are planting a flower in the flower bed. So you have to make that value f of 0 equal to 1 because you are planting a flower here. That's why the value of the f of 0 will become 1. Similarly, for the end of the array also, if it is 0, 1, 0, and 0, there are chances you can insert because adjacent to this is 0. So yeah, you can insert a flower over here. So imagine n equal to 1 and count equal to 0. Again, same condition, f of length minus 1 equal to 0 and f of length minus 2 equal to 0. Yes, both are zeros. And count is not equal to n. Yeah, count is not equal to n. 1 and 0 is not equal. So then you perform count plus plus. And here, at last, you will check whether count is equal to n. 1 is equal to, because count plus plus, the count value will become 1. 1 equal to 1? Yeah, it is true. So you will return true. You are able to plant one flower in the flower bed. Here also, count plus plus, then yeah. See, last two elements are 0 and count is not equal to n. Count plus plus. So you are planting a flower in this flower bed. So what's the value of this element should become now? It should be 1. So f of length minus 1. That value should be become 1. So this updation must be done every time. Next, you check whether count equal to 1. So count plus plus will happen. Count 1 equal to 1. Yes, it is. So you return. Similarly, you can check for other false condition also. You can take one. Anyways, this condition won't happen. F of 0 is not 0 here. So yeah, this won't happen. So these three cases done. So one is one length. The length of the array is 1. Then the other condition is for the beginning of the array, and the other condition will be for the end of the array. What about the remaining elements in between? So for that, we shall need to take, yeah, we will take this example only 1 0 0 1 0 0 0 1 and n equal to 2. So in this case, you have to take while condition while count not equal to n and one more. And yeah, initialize int I equal to 1. Why int I equal to 1? Because beginning of the array, first element of the array we have checked already. So you will start from the second element now. So I equal to 1. So I lesser than. And also last element also have been checked earlier. So length minus 1. Length minus 1. I lesser than length minus 1. Why are we not taking I lesser than length? Because last element has also been checked earlier and beginning of element of the array also has been checked earlier. Whether you can insert, you can plant a flower in that flower bed or not, in that position or not. So this is for the remaining elements. That's why you're performing from I equal to 1 till I equal to length minus 1. And you need one more variable called previous. That will be nothing but flower of 0, flower bed of 0. So why do we need this? Because if you take this value now, I equal to 1, you have to check whether previous value and the next value are 0 or not. If either of them is not 0, then you cannot what uh, plant a flower in this position, right? So that's why we need a previous value, previous equal to f of 0. So now this condition we have taken, right? So now we have to check if what if the value at that position now in case instead of 0 it was 1, if f of I equal to 1. Do we need to perform anything? Can we insert a flower in that flower bed? Flower bed? No. In that position? No. So we just do I plus plus. Before performing I plus plus, you have to initialize previous value equal to f of I. So now current value will become the previous value because for the next element to check, you have to take the previous value to that one. So we are making the current value as a previous. Then we are incrementing I plus plus. That is one condition. Else, if f of I is not equal to 1, then what does it has? It has f of I will be equal to 0, right? So this L condition will be f of I equal to 0. So for this, what you have to check? You have to check else if in this else also you have to check if previous equal to 0, right? And f of I equal to 0 and f of I plus 1 equal to 0. If all these three are 0, like if you take this example, if all the three are previous equal to 0, f of I equal to 0, f of I plus 1 also 0, then what? Then you have to increment the count value, count equal count plus plus. That means you can plant a flower in this position. So f of I will become 1. So now previous value will become f of I. So after you do f of I equal to 1, you have to initialize previous value equal to f of I. If you perform previous value f of I first and then f of I equal to 1, then it will take previous value itself, not 0 instead of 1. So you're planting something. You have to take that updated value as the previous value now. Next, again I plus plus. Here in this three condition, you have to check whether count not equal to n. That comes in the while loop itself, not required here. So this is done. If this is not the case, if any one of them is not 0, then the same condition will happen. Which one? Else or previous will be equal to f of I and I plus plus you have to perform. You cannot place a seed because in this example only, if this is 1 and here it is, you are pointing, imagine. So now f of I equal to 1? No, this is not equal to 1. So what do? You check, else condition will go. So previous equal to 0? No, it is not equal to 0. That means you cannot plant a flower in this position itself. So you are just making the previous value equal to current value and then incrementing the I value because you're moving to the next position and checking whether you can plant a flower in that position or not. So this is the logic of the program. If you want, I shall explain with an example. 1, 0, 0, 0, 1. So if let's take n equal to 2. So if you take this, at first you check length of the flower bed is 1 or not. No, it is not 1. So moving to the next condition. So length is not equal to 1. Then you check for the first element of the array. Whether it is equal to 0. No, they are not equal to 0. That condition also you will not check. Then you go to the last element of the array. Whether the last element is equal to 0. No, it's not equal to 0. So you're not checking that condition as well. That condition, which condition I explained previous to this while loop, no, that one. This this is the first and last element, and here for the length equal to 1. So this is for the remaining elements in the array. So yeah, now you go this. Now you start with the loop. So when we start with the loop, initially I equal to 1 and count equal to 0 and n equal to 2 and previous will be equal to f of 0, that is 1. F of 0, that is 1. So now while count not equal to n, yes it is correct, 2 not equal to 0 and I I1 lesser than length minus 1, 1, 2, 3, 4, 5, 5 minus 1, 4. Yes, it is also correct. So you check whether I equal to 1, right? F of I equal to 0. Yes, it is equal to 1 here. F of I equal to 1. No. Else condition you will go. So after going to else condition, you check whether previous value equal to 0. No, it is not equal to 0. Thus, you just make previous value equal to current value. That is nothing but f of 1. So that will be 0 and I will become 2. So next again, while not equal to n, yeah, correct. And 2 lesser than 4, yes, it is. Then again we check. So here it will pointing whether f of I equal to 1, no. F of then you come to else part. So previous value is 0. Then f of I equal to 0. F of I plus 1 also 0. So that means you can insert a value. So now f of I will become 1 and count will become count plus this. So once you have f of I equal to 1 and count plus plus, now previous value become f of I. F of I nothing but 1. So previous this value will become 1. So once you have this and I plus plus, I will become 3 now. Next you go for next condition. So I while count, so count equal to 1, 1 is not equal to 2. Yes, it is not equal to 2. And 3 lesser than 4. Yes, it is lesser than 4. So now you check whether pointer is pointing here. F of I equal to 1, no. So you check whether previous, go to else condition and check whether previous value equal to 0. No, it is not equal to 0. Hence you just perform previous equal to f of I. F of I will be nothing but 0 and I equal to I plus plus, that will become 4. So once again you check for the while condition whether count not equal to 1. Yes, it is not equal to 1. 1 is not equal to 2. But 4 is not lesser than 4. Hence you come out of the loop. At last you need to check if count equal to n. So 1 is not equal to n. No, this is not equal to n, hence you return false. So you cannot insert two flower in this flower bed. Now we shall code this. Uh, at first int count equal to 0 int I equal to 0. These are all required I equal to 1. These are all required for the while loop. Then we check for the first condition if flower bed dot length um, flower bed dot length equal to 1 and count not equal to n. Then you have to check if flower bed of 0 equal to 0 count plus plus. Otherwise, you need not to perform any increment. So next comes the second condition. If flower bed not length greater than 1, if that's the condition, then you have to check if first we'll check the first element flower bed of 0 equal to 0 and flower bed of 1 equal to 0 and count not equal to n, then count plus plus and yeah, flower bed of 0 equal to 1. After this, you have to check for the end of the loop also. So if flower bed of flower bed dot length minus 1 equal to 0 and flower bed of flower bed dot length minus 2 equal to 0 and count is not equal to n, then again count plus plus okay, count plus plus and flower bed of length minus 1, the last element will become 1 now. So this is for the if the length of the flower bed is 1. If greater than 1, we check for the beginning and end of the. If this is not the case, after all these conditions, you have to go to the middle elements, remaining middle elements. For that, you need a previous value. Int previous equal to flower bed of 0. So now while count not equal to n and I lesser than flower bed dot length minus 1, if you have to check flower bed of I equal to 1, then you just need to perform previous will be equal to flower bed of I and I plus plus. Else, here you have to check if flower, if okay, as previous equal to 0 and flower bed of I equal to 0 and flower bed of I plus 1 equal to 0 and okay, all these conditions are satisfied, then uh, count will become count plus plus and yeah, I plus plus will happen before that previous okay, flower bed of I will become 1, then because you are planting a flower in this position now, and then previous value will become flower bed of I and then you perform I plus plus. If this is not a condition, else you just to perform previous equal to flower bed of I and I plus plus. So all conditions are done. Now we have to check here if count equal to n, return true. If this is not the condition, return false. We will run and check. Flower bed dot length. Flower bed dot length. Yeah, been accepted. We'll submit and check. So it's a simple problem. If you have any doubts, please drop out in the comment section and subscribe to the channel for more such videos. We'll come up with another video in the next session. Thank you.